Section 1.4, problem solving in chemistry. Now what we're going to talk about today, it's going to seem fairly basic for this section, but this is a very important concept. When we get into like chapter 3 and 4 and those in there where we start to actually do this, then it'll make a little more sense. But just do it the way I ask you to do it. That's the key for this. It's very important that you follow these steps as you go through this. Once again, here's our objectives. Identify 2 general steps in problem solving, describe 3 steps for solving numeric problems, and describe 2 steps for solving conceptual problems. Alright, so let's talk about some skills. First of all, the best way, they talk about this like in a lot of things is, come up with a plan and then implement your plan. That's exactly what we're talking about. So the best way to do this in problem solving is kind of figure out, okay, how do I need to do it, and then get started doing it. Okay? So let's talk about numeric ones. First of all, the first thing you should do is analyze. Read the problem. Take a look at it. What do you know? What are your knowns? What are your unknowns? What are you trying to find? Those are things that you need to do in every problem. What you're going to see is, in chemistry, you're going to get a lot of story problems, things like that. So you're going to have to figure out, what are they asking for and what are they giving you? That's the first step. Analyze it. Then set all that stuff up and calculate it out. Figure out what the answer is. And when you're done, spend some time on this one. Evaluate it. This one drives me nuts because I watch people, I see them do things, I know they're wrong. They should know they're wrong just by looking at the answers that they get. And they don't see that because they didn't sit down and think, is that possible? I remember I teaching middle school math years and years ago, and one of the problems was, somebody buys a hat for $4 and has 5% sales tax, and how much tax is there? And the kid put down like $200 tax. Now, I don't know about you, but I don't want to live in a country where I go buy a $4 hat and I have to pay $200 in tax. And, that should have clicked right away. Hey, this can't be the right answer. But you got the answer, wrote it down. That's what I'm talking about. Evaluate. See what you got. Let's work through a couple sample problems. Every single one of these problems you could probably do in your head. That is not the point. The point is, learn how to set them up and do them, because before you get done, you will not be able to do them in your head. So they do get a little more difficult. Now, this is pretty little if you can't read it. This is in the book on page 30, so take a look at that if you can't read it on here on the screen. But let's say, for instance, you are visiting Indianapolis for the first time. Because it's a nice day, you decide to walk from the Indiana State Capitol to the Murat Center for an afternoon performance. According to the map, in figure 125, that's to the right there, the shortest route from the Capitol to the theater is 8 blocks. How many minutes will the trip take if you can walk 1 mile in 20 minutes? And assume that 10 short city blocks equals 1 mile. So let's take a look at what we're trying to do. All right, first of all, here's my knowns. This is vitally important, that we have our knowns that we're going to figure out. Okay? All right, hang on. Let me get to, there we go. Okay. Need to be able to see what I'm writing. Somehow I couldn't do that. Let's make a new one here. Okay, so once again, here's my notes. I'm going 8 blocks. I can walk 1 mile in 20 minutes, and 1 mile is 10 blocks. Those are my knowns, and what am I trying to find? I'm trying to find the time, and I'm trying to find that in minutes. So this is how I like to set up all of these problems. I always like to say, what am I trying to find? I usually put a question mark, and I'm trying to find minutes. Equals, what am I given? Well, I'm given, really my starting point is that I have to go 8 blocks. So I'm given 8 blocks. Now there's no direct conversion from blocks to minutes, wherever I'm trying to get to minutes. There's no direct conversion to that. So what I need to do is figure out a way to convert some of that. So let's kind of clear up some of this. We got too much stuff here. Okay, I do know that I can go a mile in 20 minutes. That doesn't help me because I don't know. I don't have miles here, but I do know this. I can get a mile is 10 blocks. So I could go like this, and I'm going to convert. And whenever we make conversion factors, then we want to make it so that they cancel. So if we think about this one as 8 blocks over 1, my next one, I want to have blocks on the bottom so it cancels here. So I'm going to say 1 mile is equal to 10 blocks. Okay, so I'm now in miles. These would cancel. I'm now in miles, but I want minutes, and I'm getting closer. I know that I can go, I know that 1 mile as I'm walking would be 20 minutes, so I can use that for my next thing. I'm going to run out of space here. So I could say 1 mile, we'll abbreviate, 20 minutes. And now my miles cancel, and I'm left with minutes. That's what I'm trying to find, so that's a good thing. And now all I have to do is do the math. Well, 8 divided by 1 times 1 divided by 10 times 20 divided by 1. From now on, I'm never going to talk about ones. They're just kind of irrelevant. I don't need them. So I can do this. I can say, hey, this is 8 divided by 10, times 20. And I can just kind of eliminate some of that. That's going to be a 1. That's going to be a 2. So it's going to be 8 times 2. It would be 16 minutes for me to walk that far. Now, does that make sense? Would it make sense if I can walk a mile in 20 minutes? This is less than a mile. Could I get there in 16? Yeah. And that's the idea of evaluating it. Think about it in terms of, does it make sense and could I do it? All right, I would like you right now to do these 2 problems. Do numbers 26 and 27. And I want you to stop the video so that you have time. When you get them done, turn the video back on and I'll work through them with you then. But I want you to do them first. So stop the video right now. Okay, so hopefully you did those 2. And let's go ahead and work through these problems. So 26 says, using the information in the sample problem, how many short blocks can be walked in 48 minutes? So what am I trying to find? I'm trying to find blocks, and I'm starting with 48 minutes. And I've got different conversions, and I'm trying to figure out, in this case, I need blocks and blocks to miles, miles to minutes. Okay, looks like I might be able to get some of this going here. So let's start off by converting to miles. Okay, so in 20 minutes, I can get 1 mile. So my minutes have canceled. That's still not blocks yet, but I know that 1 mile is 10 blocks. So once again, I want to make sure that miles cancel. 10 blocks here. So that cancels. So now I've got everything. I'm ending in blocks. That's what I'm trying to get to, so that's a good sign. So it would be 48 divided by 20 times 10. I'm going to kind of reduce down here. So 48 divided by 2 would equal 24 blocks. I can't run out of room there. 24 blocks. Okay. Let's try the next one, the last one here. I don't want to save that. Okay. Number 27 says, there is an ice cream shop 6 blocks north of your hotel. How many minutes will it take to walk there and back? So we want to know minutes, given that it is 6 blocks away. Blocks we can convert to miles, so blocks go on the bottom. Remember, this would be considered to be over 1. 1 mile here. I'm at miles. I need to get to minutes. I can walk a mile in 20 minutes. So that's all I need to do. Okay, once again, let's reduce down 1 and 2. 6 times 2 is 12. 12 minutes for me to walk 6 blocks. Okay, hopefully you have those, got those figured out. If not, if there's any questions on these, make sure that you bring that up in class tomorrow, and we'll go over any of those that you don't understand. this is important information. Just being able to do it is highly important. And even though those were very, very simple, you need to understand how that works before we go on. All right, if we're talking about conceptual problems are different. Numeric problems had numbers. Conceptual problems are just problems you got to figure out. Well, you're going to do the same type of thing. First, you're going to analyze, you're going to figure out what you got to do, and then you're going to solve. There's just no calculations involved when we do these. But let's take a look at this. These are usually pretty simple. Manny has to run 6 errands between 10 and 5 on Saturday. Must get a haircut, wash his car, buy stamps, rent a video, return a library book, and buy some groceries. Assume that each errand takes 30 minutes, and Manny will do only 1 errand per hour. Manny will stop for lunch between 12 and 1. Use the information in the drawing to figure out a way for Manny to accomplish all 6 tasks. Now take a look at, because there's some more things here going on. Okay, for instance, the video store is only open between 10 a.m. and 6 p.m. And the, what do we got there? I can't read it in mine. Let me grab my book here. The post office is only open from 8 to 11, you know, and so on. So as you look at all of those, there are some different things that have to happen. So each place that Manny needs to visit is open for a limited number of hours. And he's got to do all of his errands between 10 and 12, and 1 and 5, because he's going to stop for lunch in between there. So at the rate of 1 errand per hour, he must do 2 errands before lunch and 4 of them after lunch. So taking a look, which ones does he need to do before lunch? Which ones are not open after lunch, for instance, or maybe not open very long after lunch? And as you look at it, you can see, oh, the post office, that's not open after lunch, and the library is only open till 1, and he's taking lunch break up there. So he better do those 2 in the morning. And the barbershop and the car wash, they close earlier than the video store, so he might want to do those next. Where in the supermarket, it's open till midnight, so no problem there. You can do that one near the end. So that's the idea of a conceptual problem. Okay, I'm not going to spend a lot of time on this. I think you guys can understand these ideas. I'm not so worried about these as much as I am about the numeric ones. We do a lot of numeric ones throughout the year, so make sure you understand. You still have to think through these ideas. You know, you still have the idea of analyze and then, you know, solve the problem.